Hey guys, today we're going to practice sketching out the graphs of polynomials of higher degree. So to do this, there are basically 4 steps. First, you're going to apply the leading coefficient test to determine the end behavior. So right below, I have a small picture of what the leading coefficient test does. If your polynomial is positive and even, so positive and even degree, positive, even, both ends will point up. If it's negative and has even degree, both sides will point down. If it's positive but odd degree, left side is down, right side is up. And if it's negative of odd degree, left side goes up, right side goes down. Okay, so that gives you kind of a general idea of what your graph's going to look like. Second step is to find the zeros and their multiplicities. So you're going to find the zeros by factoring. And then once you have your zeros, determine their multiplicity. So how many times does a certain number show up? This is important because when you're drawing your graph, if it shows up an odd number of times, so if it only shows up once, it's going to cross the x-axis at that number. If it shows up an even number of times, so if it shows up twice or 4 times, it's only going to touch the x-axis at that number. Third step is to plot a few additional points. So you can make yourself a table and just include, a few points that we haven't covered yet. I will say that it's probably a good idea to find out what the y-intercept is going to be. And then fourth step is finally to sketch the graph. So let's just go ahead with our first example. This one says, sketch the graph of the polynomial f of x equals 8x to the 4th power minus 18x to the 2nd power. So if I'm going by the steps above, the first step said to use the leading coefficient test. So I'm going to call that step 1 to determine the end behavior. So if I'm looking at this graph, this function, the largest exponent that I see is 4. So this function has a degree of 4. Which means that it is even. Okay, second, I'm going to look at whatever number's in front of that largest exponent. So in front of that, I have a 8. So I'm going to write LC to mean leading coefficient has 8, which in our case, what's important about that 8 is that it's positive. So if this function is even and positive, I'm going to go back to my notes up here. That's this very first one, even and positive. So that means that the left side and the right side are both going to point up. So I'm just going to write that here on the side. Left side is going to go up. Right side is going to go up. And we'll save that for later. Okay, next thing, step number 2 was to find the zeros and their multiplicities. So you're going to find the zeros. So this is step 2. Find zeros by factoring. So I'm going to rewrite my function down here just so that I don't have to keep referring to the top. I have 8x to the 4th minus 18x to the 2nd. And because we're finding zeros, we're going to set that all equal to 0. Okay, so always look to see if you have a greatest common factor first. So what I noticed right away is that they both have x's. So x to the 4th, x to the 2nd. Specifically, I can take out 2 x's from each one. So if I divide by x squared, so I'm going to write down that x squared. But then also take a look at their coefficients. So this one has an 8 out front, and this one has an 18 out front. They are both even numbers, so I also know that I can divide by 2. So I'm going to put a 2 here. Okay, so now let's perform that division. For the first term, 8 divided by 2 is 4. And then x to the 4th divided by x to the 2nd. Laws of exponent just say that you have to subtract. So 4 minus 2 is 2. That would give me x squared. Now for the next term, I have negative 18 divided by 2 would give me negative 9. And then I have x squared divided by x squared. So laws of exponents, 2 minus 2 is 0. So it'd be x to the 0 power, which is just 1, so you don't need to write it. And this all still equals 0. Okay, but I want to factor it as simple as it can be. So starting with that x squared here, that I can separate right here. I can separate that into 2 separate x's. So technically it could be like 2 times x times x. Each one of those would be their own factor. Sorry, I'm going to erase that for now because it's going to get confusing. So just make sure that you remember that in your head, that x squared is the same as 2x's. Okay, but this other one, what's in parentheses, that's a quadratic equation that I can factor down even further. This is a difference of squares again, just like yesterday. So difference because they're subtracting, and squares because 4 is 2 squared and 9 is 3 squared. So I can factor this down further as, I'm going to bring down this 2x squared. But that difference of squares, I can write it as 2x minus 3 and 2x plus 3. So now everything is factored as much as it can. Now we can find our zeros. So whenever you have a number in front, so that 2, that doesn't count as part of your factors. You want anything that has an x. So starting with x, it has a multiplicity of 2 because of that exponent. But I'm still going to set it equal to 0. So multiplicity is 2, which makes it even, which means that at x equals 0, it's only going to touch. Next one I have is 2x minus 3. Set that equal to 0. If I solve this, I need to add 3 to both sides. That's 2x equals 3. Then divide by 2. So x equals 3 halves. And this is just the 1 power. Even though we didn't write it, we know it's there. So since it's a multiplicity of 1, that's odd. So that means that it is going to go through that point. And then for the third one, 2x plus 3, set it equal to 0. Since it's really similar to the one that we did, I know it's going to be the same answer, only this time it's going to be negative, so negative 3 halves. Again, this has a multiplicity of 1. Even though we don't write it, we know it's there. So multiplicity 1, which is an odd number, so the graph is going to go through that point. Okay, and then third step that it said for us to do was to find some additional points. So I'm going to put this as step 3. So I know for sure, in fact, I'll probably do it right now, that way I can already have them there. Our 3 zeros were 0, 3 halves, and negative 3 halves. So over here on my graph, I know it needs to go through 0, negative 3 halves, and positive 3 halves. Okay, but I want to know what's going to happen in between those points. So you can pick any number that's in between. Remember that 3/2 is the same as 1.5. So I'm just doing my tick mark so it's a little bit easier to see. So if I want something in between those 2 points, 0 and -3/2, I could just pick -1 and +1. So I'm going to go ahead and figure out what those should be. And the way I do that is I'm just going to plug it into the original function that we had. So let's say x equals -1. So our original function up here, 8x to the 4th minus 18x to the 2nd. I'm going to plug in -1. So your equation would look like this. Okay, so when you put this into the calculator, you get 8 minus 18, which gives us -10. Then plugging in +1, it turns out that it comes out to the same number, -10. So that helps us with our graph because for the y-axis, I'm going to count by 2s. So that 2, 4, 6, 8, 10. These are all negative numbers. That helps because it gives me another point that I can plot. So at -1, it's at -10. And at +1, it's also at -10. Okay, so now I have points. From step 1, I know that both sides have to point up. So now I'm going to sketch my graph. So starting by pointing up, has to go through that 0, touch here. This time it's going to bounce, go back and touch here, and then go through that point. So it's not the best graph in the world. You can tell it's a little crooked, but that's the general idea of what it would look like. Again, I knew to go through -3/2 and +3/2 because they had odd multiplicity, but because 0 had an even multiplicity, it only touched and came back. Okay, and that's how you graph a polynomial.